Okay, let's carry on where we left off. So obviously, like I said, we calculated each of those voltages pretty much by applying the um, formula for voltage for each of those. So we'll go back and just look at that very briefly. Um, Again, we had, just to remind everybody, that this right here was incorrect. It should have been 63.2 right there, not 6.32. So for ER1, we just took 500 ohms times the current, got the voltage, 700 ohms times the current, got the voltage, took the impedance, the X of L of each one of these, which was 490 for L1, 980 for L2, and got each of those voltages. So again, nothing earth-shattering, and again, apologize for my writing, but this should be 63.2 milliamps, not 6.32. So a little error there in NIDA, but that happens. So let's proceed. Let's see what else is in store for us in the next few slides. So we've got this right here. Remember EA, when we when we do the formula for it, we take the square of ER and the square of X of L. And what they did was they added these two ERs. And again, we got a little bit of a rounding thing going on here. But if we add the 31 and 31.6 and the 44.2, and we add the 31 and 61.9, we get the values that we see over there in our formula. So here's the 31.0 plus 61.9, and over here is the 31.6 and the 44.2 added together. So both of those come out to be 75.8 squared and 92.9. And again, I'll try to write that out because I want to make sure you absolutely understand that. This 75.8 is 31.6 plus 44.2, and that gives us the 75.8 there. The 92.9 is the addition of these two added together to give us the 92.9. That's where those come from. Square both of those. We'll do it over here on our own little calculator so you can see. So if we open parentheses, say 75.8, and we square that, plus 92.9, and we square that. That equals 14,376.05. Get the square root of that, and we get this 119.9 volts that you see here. So the same math, same answer, so I think we get that, and that's just a different way of doing it than what we used to have to do before, just because we've got a RL circuit now. Alright, so just a reminder, that formula for that was right up here. Didn't point that out a while ago. But to get the EA, we took the ER total squared plus the EL total squared, got the square root of that, and there you go. Just that simple. So again, it's a process, and it's a rather lengthy process, but if you follow it, it works just fine. So let's see what else is next. And of course, we're going to get some little rounding difference there. We got 119.9 as opposed to 120. That's close enough. Alright, so here we go. And we're going to come up with what we need to here. So I'm probably going to be back and forth while I'm making some calculations. I'm going to try to do it live. But bottom line, we're wanting E of R1, E of L1, E of L2, E of L3. So obviously, just to examine this circuit, we've got three different coils here. We've only got a single resistor, so our total will be easy. We've got to get the total of 3, but we're going to have to do each individual X of L simply because we want the E of each one of those. So we could go ahead and add them together and get an X of L total, but if we do that, then we don't have the X of L of each of those. So remember, X of L is 2 pi FL. So we're going to go 2 times pi times frequency, which is 10. And this is in kilo, and all of our coils are in millis, so we don't have to worry about units. And then we're going to say times, and we'll start with the first one, 10. Alright, that gives us 628 ohms. So X of L for this first guy, let's come over here and put that value in. I thought I had a text, but I don't. Alright, so thought I could type text rather than having to write. But anyway, X of L1 equals 628.32 ohms. 628.32 ohms. Now, let's do the next one. So let's clear. 2 times pi times 10 times 15 equals 942.48 ohms. So we'll write X L2 equals 948.48 ohms. Then last but not least, let's go over here and calculate our last one. We'll say 2 times pi times 10 times 5 equals 314.16 ohms. So let's try it again. 314.16 ohms. Again, I know my writing's pretty terrible, but I'm doing this with the mouse. And this is just the best I can do. So there we go. We've got that. So if we've got our X of L, we can now have our X of LT simply by adding all 3 of those together. So I'm going to come back over here and do that, because we do need that to be able to get current. So, whoops, I did not mean to do that. I don't think I have an undo. Yeah, I do. There we go. So we're back. So, let's go back to our calculator. Let's add 628.32 plus 948.48 plus 314.16, and that equals 1890. I'm going to call it 1891. We're going to round that puppy. So X LT equals 1891 ohms. Alright, so we've got that far. Now, our next step is to get our total impedance. And remember, we can't just take and add. We've got to do this wonderful little formula where we have to take, it's the square root of R total plus the square root of X of L. So R total is easy. I'm going to circle R total so we can remember. I'll use a different color. We'll use green. So here's R total. Here's X of L total. Got to square both of those and then get the square root. Now this I'm going to convert to 1.891 K ohms, because this is in K ohms, and that way I'm using the same units. So let's clear. squared plus 3.2. Whoops, I did not use the units. Let's start over. We'll go 1.891 squared plus 3.2 squared equals, and get the square root of that, 3.7. So my ZT is equal to 3.72 k ohms. I'll have to write that under here, k ohms. So there we go. So now we've got ZT, so we can get IT. IT is our applied voltage divided by our ZT. So I'll clear over here. So that would be 10 divided by 3.72. Now this is in K, so my answer is going to come out in millis. 2.69 milliamps. So IT is 2.69 milliamps. So I'm going to have to take that 2.69 and use it multiple times. So I'm going to come over here and clear my calculator, and I'm going to store that in memory. I'm going to say 2.69, and this is in millis, so I'm going to store that. I'm going to add that in my memory, and that way I can make these calculations quickly. So I'm going to multiply that times either the R or the X of L. And all of these are in, we'll make them in K. So I'm going to have to put 0.628, 0.948, 0.314 for each of these. I won't have to for this guy because he's different. So we'll see what happens when we do that. All right, here we go. So I'm going to take 3.2 times what's in my memory, and that's going to give me 8.608 volts. And then I'm going to take L1's ohmic equivalent impedance, and I'm going to say 0.628, because remember this is in K. Actually, I need to do that on my calculator, not over here. 0.628 times what's in my memory, and that's going to be 1.68 volts. Do the same thing for L2, which is 15. So 15 times what's in my memory. Whoops, that doesn't seem right. Oh, I used the wrong value. My bad. I said 15. I was looking at L2. I need the X of L2, so 0.948. This is how easy it is to get confused. And still didn't type something in. I'm trying to be too quick here because we're running out of time. So 0.948 times what's in my memory equals 2.55. And let's see if we can hurry and get this last one before the video ends. So it's going to be 0.314 times what's in my memory equals 0.845 volts. And let's see if I'm right. Yes. So again, we had to go through quite a process to get there. And I'm going to end this video so we can go to the next part of it. But it is a step by step by step by step. And you got to follow those steps and you got to understand what's going on.